Hello and welcome to Vidya Mandir Trust. I am Pankaj Kumar and this is the first lecture of second round and the topic is trigonometry. So first of all, what is trigonometry? So when we discuss about this word, then two words come in our mind: trigon and metron. These two are Greek words and its meaning is measurement of sides of triangle. All right, measurement of sides of triangle. And when we start to measure the sides of a triangle, then some more interesting things is going to be discussed. Yes, I am talking about angles. All right. So the first chapter of the trigonometry is measurement of angles. Okay, so let me write the complete syllabus of class 11th, 12th and IIT JEE, and thereafter I will start with the first chapter. All right, so the first chapter is what? Measurement of angles. Measurement of angles. So we will study about measurement of angles. We will study different systems to measure the angle like degree, radian and grade system. Thereafter, in the coming classes, we will introduce you with trigonometrical identities. And yes, we will define some trigonometric functions. So the second chapter is what? Trigonometric functions. All right, and when you equate, for example, we will discuss about sine, cos, tan, cot, sec, cosec, etc. So if you will equate this sin x with some constant like 0 or some constant like 1, or if you will equate two trigonometric function, then it becomes what? An equation. So thereafter, we will discuss trigonometric equations and its general solution. This is the third chapter, trigonometric equations and its general solution. So in 11th, we will start with measurement of angles, thereafter trigonometric function, thereafter trigonometric equations and its solution. Certainly, we will discuss general solution and particular solution as well. Thereafter, properties of triangles will be discussed. Properties of triangles. This is also a very interesting chapter. And one more chapter, heights and distances. Heights and distances, which is related to solve general life problems by using trigonometry. So it is a really interesting chapter, heights and distances. And at last, so all these chapters is to be read in class 11th, and after these discussions we introduce inverse trigonometric function, but not in 11th, in 12th. So in 12th we will discuss inverse trigonometric functions, and it is really interesting. Remember, the word inverse is over here. So certainly trigonometric functions and its inverse will be discussed, and it is very interesting. Actually, we have to study it in class 12th, but I would like to say something that only 1-1-1-2 functions are invertible. But in general, trigonometric functions are not invertible in its domain. So to discuss this chapter, to start this inverse trigonometric functions, we restrict their domain and then we discuss. Okay, so this chapter will be discussed in class 12th. But today we are going to start the very first chapter of trigonometry, and yes, that is nothing but measurement of angles. So let's go to start this very first chapter. All right. So the chapter is what? Measurement of angles. So first of all, how we measure the angles, how the angles form. Okay, so first few minutes will be dedicated to very basic thing, and then thereafter we will accelerate. So first of all, measure of angles means what? Take this initial line and this O as the initial point, and then if you will fix your thumb over A, and this is called what? Initial side. Certainly initial side means the side from where you are going to start. This O is initial point, and if you will rotate this anti-clockwise sense, okay, if you will rotate this in anti-clockwise sense, then you will be over here, and this is what? This is terminal side. Okay, so the measurement of rotation from initial side to terminal side is called angle. And what is the sense of rotation? The sense of rotation is anti-clockwise. Anti-clockwise. So whenever your sense of rotation is anti-clockwise, then always take it as positive angle. All right, so we are fixing our point over here. This is the initial point, initial side, and we are doing a rotation through anti-clockwise, and therefore our angle, the measurement of rotation will be positive if the sense of rotation is anti-clockwise. So note it down. Now, think, if this is your point and this is your initial side, this is your initial side, and if you are putting your thumb over here and you are moving this in clockwise sense, in which sense? Clockwise. So if the sense of rotation is clockwise, then we will say that this angle is negative. So negative angle if the sense of rotation is clockwise. So this is terminal side, and from where we start is called initial side. So this is the point, this is the initial point, this is the initial line from where the measurement of rotation has started is called initial side. And after doing the rotation, we are over here. So if this is OA, OA is initial side, we are over here OB at OB. So this OB is a terminal side, but the sense of rotation is negative. The sense of rotation is clockwise. Therefore, we will take this measurement as a negative angle. All right. So for example, think you are over here at the origin. This is the positive x-axis as an initial side, and you have started your rotation from here, and you are over here in the positive sense, and think this is 30 degree. Then we will take this 30 degree as positive 30 degree, but if this is the initial point and you are rotating, but the sense is different, but the sense is clockwise, then this will be minus 30 degree. All right. So if you will rotate through 60 degree in clockwise anti-clockwise direction, then it will be plus 60 degree, but in clockwise sense it will be called minus 60 degree. So this is a very fundamental thing, that in anti-clockwise sense the angle will be positive, and in the clockwise sense the angle will be negative. All right. So now we are going to define revolution, and what is the relation between revolution and degree, and thereafter we will correlate degree and radian after defining radian. Okay, so this is the very first class, so certainly we will discuss very basic things. All right. So now, what do you mean by a revolution? A complete revolution means what? A complete revolution means what? Means, think this is a point, this is your initial line. You have started your rotation from a point on this initial side, and you have started the rotation. Okay, you have come over here, come over here, come over here after rotation, and finally you are reaching on the same initial side. So you were started from this point and you are reaching on the same side. This is your initial side because you have started from here and the rotation has completed over it again. So our initial side and terminal side coincides. So you can easily understand that this complete rotation will give you how much angle? 360-degree angle. Okay, 360-degree angle in one revolution. One revolution. So if I will ask you about 1 degree, then what you will say? You will say 1 by 68th revolution is equals to 1 degree. Okay, one complete revolution means what? 360-degree angle is going to be obtained. All right, and we all know that if we start from this point A and after rotation we reach at the point B, then certainly this is 180 degree. You all know all these fundamental things already. All right, so now I am going to introduce you with the radian measure, and thereafter we will see the relation between radian and degree. All right, so now what is a radian measure? What is a radian measure? Before writing any definition, let me discuss it. Think, this is a unit circle. This is what? Unit circle. What is unit circle? Its center is at O and think its radius is 1. Okay, its radius is 1. Now I want to make an angle. Remember its radius, it is a unit circle. Unit circle means what? A circle with center 0, 0 and radius is 1 over here. And now we have to take an arc length of 1 and then we have to make something. So take an arc length of 1. So this is A and go with the circumference, and after reaching at B, we are getting some angle over here, theta. And this arc length AB, this arc length AB is of 1 unit. This is equals to the radius of the circle. Radius of the circle. All right. So this theta is 1 radian. Hence, this theta is 1 radian. Always remember. So 1 radian is the angle made by the arc length equals to the radius. This is the final definition. Okay, in books you can see if you have a unit circle and if you will take unit length of arc length as unit length, then you will get 1 radian. Okay, so let me write one definition and then I will generalize it. Okay, and you will understand everything. So now in unit circle, 1 radian is the angle subtended by the arc of length 1. Always. So here you can see L is equals to 1, R is equals to 1. Therefore 1 radian. So here theta is what? 1. Your L is 1, your R is 1. But in general this is the formula. Okay. In unit circle, 1 radian is what? The angle which is made by the arc length 1. But think, if your circle has the radius 5 unit, if the circle has the radius 5 unit, its R is 5 units. And if we will take an arc length of 5 unit, then what will happen? Think, this is A, this is B, and if we will take this arc length AB as 5 unit, then what will happen? Again, you will get 1 radian. Certainly, you will get what? You will get theta is equals to 1 radian. Okay? So now what is the definition? In any circle, if we will take the arc length equals to its radius, then the angle subtended by that arc length to this will be 1 radian. For example, if your arc length is 5 and your radius is 5, then theta is equals to L by R, which is 5 by 5 is equals to 1. So what is the relation between the angle in radian, the arc length and the radius? Certainly theta is equals to L by R. Okay, so we all should remember this. Theta is equals to L by R. But now some more interesting things. I am going to ask some more interesting things. All right. So now let me draw a picture over here. So this is the origin. And now I am taking an arc length AB as 5. The arc length AB is of 5. L is equals to 5. And we are taking R is equals to 2. Then how many radian is going to be subtend over here? What shall you say? Theta is equals to L by R. So how many radian? So L is 5 and R is 2. So 5 by 2 radian. But in anti-clockwise sense. But if I will draw the figure in this sense, think if this is your A, this is of radius 2, and if we will take your B in clockwise sense, then what will be your theta? Certainly the theta will be as same, but as the theta is in negative direction, in clockwise direction, therefore it will be minus 5 by 2 radian. All right. So if I will take a circle with radius 3, and arc length, think A to B, this arc length is also 3. Then what will be this angle? Certainly this will be 1 radian. Okay, so if radius and arc length is equals, then the angle will be 1 radian. Okay, if the radius is 10, and this arc length from A to B, if this arc length is equals to 10, then certainly the angle subtended by this arc length over here will be 1 radian. Why? Because the arc length is 10 and the radius is also 10, and therefore this kind of things will happen. Okay, so I hope you understand the radian system. Now one interesting thing, and thereafter some very interesting questions. Okay, so think if I will take a circle over here, okay, and this is a point O, and this is the radius R. So now what are we doing? We are going to start from the point A, and we are rotating. We are going to rotate over this circle, and finally we are coming over here. Finally we are reaching to A. Then how many angle? What angle has subscribed? Okay, we have to discuss it. But what is the arc length? So the arc length will be equals to what? The circumference of the circle. Because we have started from this point, and after rotating we are reaching over here. So the whole circle is the arc length. So it will be what? 2 pi r. Okay, and what is our r? Certainly it is r is equals to r, because this is the radius. Then what will be our theta? So theta will be what? L upon r. So it will become what? 2 pi r by r. So we are getting what? 2 pi over here. So after a complete rotation, we had the angle 2 pi. And in degree system, after a complete rotation, we had what? 360 degree. And from here, we have seen after one complete revolution, in radian system we have 2 pi, but in degree system we have 360 degree. So what shall you say? Certainly, you will say you will say what? We have seen during a complete revolution. What have we seen? That 2 pi radian is going to be obtained, and at the same time in degree system 360 degree angle is going to be obtained. All right, so 2 pi radian is equals to 360 degrees. So what shall you say? Pi radian is equals to 180 degree. So what shall you say? 1 radian will be equals to 180 degree by pi. But in another way, what shall you say about 1 degree? 1 degree will be equals to pi upon 180 radian. Okay, so we have to remember this formula. Okay, so now think, if we have 1 radian is equals to 180 degree by pi, so what will be about pi by 3 radian? For example, if we will discuss about pi by 3 radian, then what will happen? So 1 radian is equals to this, so pi by 3 radian will be what? Pi by 3 into 180 degree by pi. So pi to pi cancel and 3, so we will have 60 degree. Okay, so this is the conversion formula. So 1 radian is equals to 180 degree by pi. Therefore, pi by 3 radian will be what? Pi by 3 into 180 by pi, which is 60 degree. So in the radian system, if you have pi by 4, in degree system that will be 60 degree. All right, if we will discuss about pi by 4 radian, then what will happen? We will take what? 180 by pi into pi by 4. So pi to pi cancel and 45 degree. So can you convert pi by 2, pi by 3, pi by 6? Certainly you can convert, and you can get what we can see in the radian system or degree system. And for example, 1 degree is equals to pi by 180 radian. And then if I will ask you about 60 degree, then what shall you do? Pi by 180, and since 1 degree is pi by 180 radian, therefore the 60 degree will be pi by 180 into 60, and certainly this is pi by 3. What about 90 degree? What about 90 degree? For 90 degree, what shall you say? 90 degree into pi by 180, and certainly you can see what? Pi by 2 radian. So 90 degree is equals to pi by 2 radian. So we can convert degree into radian and radian into degree very easily. But you should remember one more thing. In degree, 1 degree is equals to pi by 180 radian. And you should also remember that 1 degree is equals to 60 minute, and 1 minute is equals to 60 seconds. This is really interesting. 1 degree is equals to 60 minute, and 1 minute is equals to 60 seconds. And I will let you to know how can we convert the radian into degree and degree into radian. But before that, there is a very beautiful relation between the set of real numbers and circles. So let me introduce you with that. All right. So think, if we have a circle over here, we have what? Unit circle. Okay. And let's denote the origin over here. Let's denote the origin over here. Let's call this point as 0. And then let me draw a straight line over here. Let me draw a straight line over here. This is your point A. This is your point, center of the circle, C. And now, let me ask you one thing, that you have the points in the positive direction and the points in the negative direction. Okay, so corresponding to every real number, we have the points on the circle, and that is going to make the radian angles. Means if you have to make, think, we are going to roll this. Ek samay, one time this one will be over here. Okay, so if we will join this point with this, then certainly this angle will be what? 1 radian. And another time you can see this point, when we will roll this, then this point will be over here, and this is 1 radian. But if we will join these two, now our arc length is what? 2 unit, and 2 by radius, because this is a unit circle, therefore radius is 1, and certainly this will be what? 2 radian. Again, after rolling this, we are going to get 3 over here, and if we will join that point with 3, then certainly this angle will be what? 3 radian. How can you say this? This is your point A, and think this is your point C. Then your L is what? The length of arc is what? 3 unit. And what is the radius? Radius is 1. Therefore, what will be your theta? L by R, which is 3 by 1, therefore 3 radian. So corresponding to every real number, if you will think, if I'm going to roll that straight line over here, and we will get, we are getting some points like 20 over here, then the arc length from this will be what? 20, and the angle this will be what? 20 radian. This point is not exact, but yes, it is giving you a sense that as we are rolling this straight line in anti-clockwise sense, then every point on the straight line is somewhere on the circle, and that is making a radian, that is making an angle over that in terms of radian. All right, so these were the things in anti-clockwise sense, and same thing can be seen in clockwise sense. And what will happen? It is really interesting. So if you have a point over here, and now we are moving in clockwise sense, then you can see if your point is over here at -1, then we can see this angle is what? Certainly -1 radian. Because the sense is clockwise, therefore this will be -1 radian. Why? Because this arc length is of length 1. This radius is 1. Therefore the theta will be 1 by 1 radian. But as the sense is negative, therefore it is -1 radian. And similarly, if your point, this -2 will come up over here, then you can see that the arc length is 2 and the radius is 1, and therefore what will be your theta? Certainly -2 radian. Similarly, for -3 radian, -4 radian, you can see the things. So now we have compactified this real number system on a unit circle. And for every real number, there corresponds an angle in radian. Okay, so this was a relation between real numbers and radian system. All right, so now we have to discuss some more interesting things over here. All right, so now I am asking you one thing. You all know one thing, that pi radian is equals to 180 degree. All right, you all know what? Pi radian is equals to 180 degree. Now I am going to ask you something really interesting. What is that? Let CK be a circle for all naturals K. All naturals K. So we are going to make a system of circles. Okay? For all naturals K, there is a circle CK. So let me draw that. First of all, let me draw that. And thereafter, we will write the question and we will ask also. If I will write the question completely, then it is not interesting to read the whole question at a time. Okay? That's why CK be a circle with all naturals. So natural starts from 1, whose center, whose radius is equals to K, and their radius is also K. All right, means what? Means if we are going to draw a circle C1, then its radius will be what? Its radius will be 1. So let's go to draw C1. This is your C1. And what is its radius? Certainly it is 1. Okay, and now we will draw some more circles, don't worry, but let me write something over here. So CK be a circle for all naturals K whose radius is K, and a particle at A 1, 0 starts to move on this circle, and from here 1, 0 the particle starts to move on this circle. So let me take this point to move, and it stops after making 1 radian, means what? Starts to move and travels through K distance. Means if the radius of the circle is K, then it will travel to K distance. So if the radius of the circle is 1, then it will travel to 1 distance. And then it jumps to circle CK plus 1 in its radial direction, or tab, and then it jumps to the circle CK plus 1 in its radial direction. What does they mean? This means now this is your C1, and after C1 what will be there? C2. So now it will be jump to C2, and along the radius, means in the radial direction, and now it will move to 2 distance over here. Now this distance is 2. Why? Because now this circle is what? This circle is of radius 2 unit. So if your circle is CK, then its radius is K. Means if the radius of the circle is 2, then the particle will move up to 2 unit, and then it will stop, and again it will change its direction, and it will change its direction in the radial direction, means in this direction, and you will get your circle like this. This is your C3, this were your C2, this were your C1. And now what will happen? The particle again move with 3 unit. Okay? So if I will ask you what is this angle, you will say 1 radian. Why? Because for the circle C3, this length is 3 and the radius is also 3. So the angle will be 1 radian over here. For the circle C2 also, the angle is 1 radian. This angle is certainly 1 radian because this length is 2 and the radius is also 2. And for the first circle, the angle is also 1 radian. Now what will happen? So after rotating with 3 unit, again this circle will shift to somewhere. Again along this radial direction, what will happen? This is our C4. So now this has traveled to this, up till here. Up here again what will happen? This will move. This movement will be happen. This is your 4, then this will also 4 unit. And then again you will get 1 radian angle over here. In each case, the angle is 1 radian. Okay? And again, this will change its direction if we will draw what? C5. This is our C5 and we will be over here. This length is 5 and this radius is also 5. So again we will get 1 radian over here. Now again what will happen along this direction? Okay, we will have another circle. Let me draw with another color. Certainly we will have this circle. This is what? This is C6. You can make better figure, but don't worry. And now we will travel through this 6 unit. This 6 unit. This 6 unit. And this radius is also 6. So finally this angle will be 1 unit also. This angle will be 1 unit also. But one more thing. one more thing, that again you have to take in the radial direction, it will shift to the consecutive, the next circle. So now, okay, and now this time you can see this radial vector will cross this x-axis again, because this is of 7 unit, then you have to move to 7 unit again, okay, and now this is your radial vector. So finally, again from here to here, the distance is what? 7 unit, and the radius is also 7 unit. So certainly this angle will be 1 radian again. 1 radian again. So what was the question? Let me explain it beautifully. That CK be a circle for all naturals K whose radius is K. Means, for example, C1 was a circle with center 0, 0 and radius 1. C2 was a circle with center 0, 0 and radius 2. C3 was a circle with center 0, 0 and radius 3, and things like this. And the particle starts to move from 1, 0, and after moving to one direction, one length, means the equal to the radius arc length, it jumps to next circle. And now the next circle has radius 2 because that is C2. CK has the radius K. So on C2, the radius is what? 2. So it will move up to 2 direction. And after moving to 2 direction, it jumps to the 3rd circle, 4th circle, 5th circle, 6th circle. And then we have seen 7th circle. Then what is the least positive integer n so that Cn completes first revolution? Okay, so you are asked for what is the least natural. So we have seen that C4, this were C5, this were C6, and this were C7. So from figure it is clear that n is equals to what? 7 is your answer. But I have made this figure without any graph. This is a rough sketch. Then how can you say this? So what is the way to decide that how many circles will be there? The way to decide is what? Our n, if our n means circle Cn will complete one complete revolution, then certainly this n will be greater than or equal to what? 2 pi. Okay, so we have to get this positive integer n, this least positive integer n, which is greater than or equal to 2 pi. So we have to find the least positive integer n, which is greater than or equal to 2 into 22 by 7. And this is what? 2 into 22 by 7 is what? 6 point something. 6 point something. So the first integer which is greater than 6 point something is what? N is equals to 7. So after the 7th revolution, by following this rule that you have a circle CK, and for all naturals K, the radius is K, the particle is moving the distance K. Okay, so we are getting what? For n is equals to 7, we will complete our first revolution. All right. So in the coming classes, we will discuss, let me discuss some more questions over here. And thereafter, in the next class, I will discuss how can we convert degree to radian and radian to degree. Okay, so it will be a very interesting class in the coming sessions. And thereafter, we will discuss many things. So the next class is dedicated for the problems that how can we convert degree to radian and radian to degree with minutes, seconds, and many more things. Okay. So 2 basic questions are over here. Certainly, we will discuss the convergence in the next lecture, but 2 very basic questions are over here. In the question number 1, you can see what? A wheel makes 360 revolution in 1 minute. 360 revolution in 1 minute. But before saying about 360 revolution, I will ask you, 1 revolution means what? 1 revolution means 2 pi radian. Because we have discussed that in 1 complete revolution, 2 pi radian will be there. So in 360 revolution, how many radian does it turn? Certainly 2 pi into 360 radian. All right. So in 360 revolution, what will happen? 2 pi into 360 radian. Okay. All right. And what the question is saying? A wheel makes 360 revolution in 1 minute. So what angle has subtended in 1 minute? This much of radian. So what shall we say? In 1 minute, how many radian that the wheel has turned? Certainly 2 pi into 360 radian. And 1 minute contains how many seconds? 60 seconds. I have discussed to you that 1 degree is equals to 60 minutes and 1 minute is equals to 60 seconds. Okay, so 1 minute contains 60 seconds. So in 60 seconds, how much radian has it turned? This much of radian. So in 60 seconds, it turned to 2 pi into 360 radian. So if I will ask you in 1 second, what will happen? In 1 second, what shall you say? Certainly you will say 2 pi into 360 upon 60. So this is what? 6 means what? 12 pi radian. Is this all right? So first question has done, 12 pi radian. All right. So now what the second question is saying? So let's go to do question number 2. What the question is saying? In a circle of diameter 40 centimeter. So a circle and its diameter is what? 40 centimeter. Means this AB has the length 40 centimeter. All right. The length of the chord is 20 centimeter. And there is a chord like this. Say this chord as CD, and the length of this CD is 20 centimeter. All right. Find the length of minor arc. So if this is a chord, let me explain over here. If this is the chord CD, then this chord has divided this circle in 2 parts. The minor arc is what? This CD, and the rest is what? Major arc. All right. So you have to find the length of the minor arc, and certainly we can do it. How? By using the relation theta is equals to L by R. But what is theta over here? What is L? What is R? So certainly we have to make a figure like this. So we can see our OD is equals to OC is equals to R, and this CD is our what? Chord, and CD is also equals to R, which is what? 20 centimeter. So in the triangle OCD, you can see that this angle is what? 60 degree. Okay. So we can see we have to find the length of what? Minor arc. Okay. So this CD, what? This CD is 20 centimeter, but we have to find the arc length of CD. This is the symbol of arc length of CD is what? So say this arc length of CD as L. Okay. And if the theta is what? 60 degree. This means what? How many radian? So 60 degree into pi upon 180 radian. So this will become what? Pi by 3 radian. So your theta is what? Pi by 3. Your L to be found. So your theta is pi by 3. L is the required minor arc, and R is what? R is given as 20 centimeter. So therefore theta is equals to L by R. Means what? Means what? Means pi by 3 is equals to L upon 20. So finally L will be what? 20 into pi by 3. Okay. So your L, length of the minor arc, will be what? 20 into pi by 3. Okay. So these were some very basic questions. In the next class, I will come up with the conversion, very many questions related to the conversion from degree to radian and radian to degree, and many more interesting general life problems. Okay. Thank you.